Geometry Common Core Regents Exam, June 2015, answer key. Part 1. Answer all 24 questions in this part. Each correct answer will receive 2 credits. Utilize the information provided for each question to determine your answer. Note that diagrams are not necessarily drawn to scale. For each statement or question, choose the word or expression that of those given best completes the statement or answers the question. I would also like to remind you at this time that at the end of your Regents booklet, you do have a reference sheet that has conversions on there, as well as formulas for areas, Pythagorean theorem, as well as volume for various figures. So which object is formed when right triangle RST shown below is rotated around leg RS? So as you can see, we have a right triangle, and as we know and we have seen, we will get choice 4, a cone. Number 2, the vertices of triangle JKL have the coordinates 5, 1, -2, -3, and -4, 1 for JK and L. Under which transformation is the image for triangle J', K', L' not congruent to triangle JKL? So we know that the transformation, without even looking at the choices, where you wouldn't have congruency, is anything with a dilation. Okay, and obviously we see that right here for choice 4. It preserves angle measures but does not preserve distance. So as a result, dilation will not give you a congruent image after performing a transformation. Number 3, the center of circle Q has coordinates 3, -2. If circle Q passes through point R, 7, 1, what is the length of its diameter? So theoretically, if we have a center with the coordinates and its circumference passes through this point, then we can find the distance of the center from the point of the center and the point that's on the circle using the distance formula, and as a result we would find the distance of the radius. And in order to find the length of the diameter, which is what the question is asking us to do, all we have to do is double the value of the radius. So we'll start with the distance formula, but I will replace it with the distance for the radius is equal to the square root, the change of x. So my first x value I have is 3, and the second is 7. So I'll start with 7. 7 minus 3 square plus my y value. Since I started with the 7, I have to go with the 1. 1 minus a -2, which makes this a plus square. So you have to have that distance formula memorized for the regions. The difference of 7 and 3 is 4, plus 2 plus 1 is 3 square. I get 16 plus 9, which is the square root of 25, and we know the distance of the radius from the center to the point on the circle is 5. So that means the diameter is double the 5, which gives us a value of 10, so that is choice 3. Number 4, in the diagram below, congruent figures 1, 2, and 3 are drawn. Which sequence of transformations maps figure 1 onto figure 2, and then figure 2 onto figure 3? So I can see that figure 1 to 2, the transformation would be a translation, and to go from 2 to 3, that would be a rotation. So translation followed by a rotation is choice 4. Number 5, As shown in the diagram below, the angle of elevation from a point on the ground to the top of the tree is 34 degrees, and I see that labeled already in the diagram. If the point is 20 feet from the base of the tree, so the base is always along the ground, so the point is 20 feet, I'm going to label that. What is the height of the tree to the nearest tenth of a foot? Because I'm dealing with a right triangle and an angle measure, and I need to find a side that's not the third missing side, it's only the second, I need to use trigonometry. So with regard to this angle, I'm looking for its opposite side and I have its adjacent side. I'm not dealing with the hypotenuse, so the only trig function that does not deal with the hypotenuse is the tangent function. So let's recall Sohcahtoa. This will help you to recall any of the trig functions, and as you can see, TOA does not deal with h. So we have tangent of the angle, 34 degrees, is set equal to the side that we're looking for, the opposite side x, over the adjacent side of 20. I do need to cross multiply, so 20 tangent of 34 degrees is equal to x, and make sure that you're in degree mode when you check your calculator. So the height of the tree is approximately equal to 13.5 feet. So that is choice 3. Number 6, which figure can have the same cross-section as a sphere? The only one that I can conclude that would have that is choice 2, because we have a circular base here, so that's the closest to a sphere as we're going to get. Number 7, a shipping container is in the shape of a right rectangular prism, so that's important information to denote, with a length of 12 feet, a width of 8.5 feet, and a height of 4 feet. The container is completely filled with contents that weigh on average 0.25 pounds per cubic foot. This is a value we're going to multiply to the volume of this shipping container that's in the shape of a right rectangular prism, so that's length times width times height. And the question is, what is the weight in pounds of the contents of the container? So length times width times height of the rectangular prism is 12 times 8.5 times 4, and we get 408 cubic feet. Now we multiply that to 0.25 pounds per cubic foot. We can cancel out the cubic feet and get a value of 102 pounds. Number 8. In the diagram of circle A shown below, chords C, D, and E, F intersect at G, and chords C, E, and F, D are drawn. Okay, so none of those chords go through the center of the circle, so I'm not dealing with a diameter or a semicircle or anything like that. So now I have to think of the other properties of chords. So now we evaluate each of the choices here in the multiple choice in order to answer the question, which statement is not always true? If you evaluate choice 1, which is line segment CG, is that congruent to line segment FG? Okay, as you can see visually, they're clearly not the same. And as you can see between the two triangles here, they are not the same size. So although I could probably conclude that these two triangles are similar, we cannot conclude that they are the same. So this may be our answer. But let's check the other three just to prove that that could be the case. Number 2, angle CEG is congruent to angle FDG. That is true. And the reason as to why is that they are inscribed angles that open up or intercept the same arc. And the arc that they intercept is CF. So this is a true statement. Angle E basically is congruent to angle D because they are inscribed angles and they open up to the same arc, so this is not the answer we're looking for. Number 3, we have a proportion which proves similarity. So CE over EG, so CE over EG is equal to FD over DG. So to show that they're in proportion, we are talking about corresponding sides that would be in proportion, and as a result, this does prove to be true, so this would not be a likely answer. And for number 4, triangle CEG is similar to triangle FDG. Yes, I would suspect that they are similar to each other because they are not the same. So the one that is not always true is in fact choice 1. Number 9. Which equation represents a line that is perpendicular to the line represented by 2x minus y is equal to 7? In order to determine a line that is perpendicular to another, we need to have negative reciprocal slopes. And what that means is that we need a slope that is flipped and negated compared to the original that's given. So the one that is given is 2x minus y is equal to 7, and we want to get all our lines equal to y, so I'm going to subtract the 7 and add the y, so we get 2x minus 7 is equal to y. So the slope of this given line is 2, the coefficient of x. So the negative reciprocal slope of a perpendicular line would be to flip it, which is 1/2, and to negate it, which is a negative 1/2. So perpendicular slope is equal to a negative 1/2. So the only value that has a negative 1/2 as its slope is choice 1. On the other hand, and in case you didn't know, if you were looking for a line that was parallel, you would have the same value for the slope, but a different y-intercept. I'm just going to highlight the negative 1/2, the coefficient of x. Number 10, which regular polygon has a minimum rotation of 45 degrees to carry the polygon onto itself? So the way in which I would determine this answer is to find out what the exterior angle values are, and we know that the sum of all exterior angles of any polygon is equal to 360 degrees. So if we look for an angle, so let's say this is the length of a side, or an example of a side, and the exterior angle right here has an angle measure of 45 degrees. All we have to do is take 360 and divide it by the number of sides and see which one gives us 45. So we'll start with the octagon. We know that an octagon has 8 sides, so 360 divided by 8 is equal to 45. So this one looks like it works out, but we'll just move forward. 360 divided by 10 gives us 36 degrees, so we know that doesn't work. 360 divided by a hexagon of 6 sides is equal to 60 degrees, and a pentagon, 360 divided by 5, is equal to 72 degrees. So that just proves for sure that octagon is the way to go. Number 11, in the diagram of triangle ADC below, EB is parallel to DC. AE is equal to 9, ED is equal to 5, and AB is equal to 9.2. What is the length of AC to the nearest tenth? So ultimately, we're looking for the entire length of AC. We know the entire length of AD, which is 14. There's two ways in order to solve this problem. You can do it in parts. for instance, AE over ED is equal to AB over BC, find out what the value of BC is and add that to 9.2 in order to get AC, or you can do it in whole and parts. So I prefer to do it in whole and parts. 14 over 9, the given value, is equal to the whole entire side AC over 9.2. Cross multiply, so 9.2 times 14 over 9 is equal to x, and that will give us the length for AC. So we get x is equal to 14.3, and what we just applied is what we call the side splitter theorem. And what that theorem states is that if you've got parallel lines in two triangles, then their sides are in proportion. Number 12. In scaling triangle ABC, shown in the diagram below, the measure of angle C is equal to 90 degrees. Which equation is always true? Okay, so theoretically we already know about right triangles in terms of trigonometry that their cofunctions are congruent or the same. So the cofunction is going to be the sine of one angle is equal to the cosine of the other acute angle of a right triangle. Number 13. Quadrilateral ABCD has diagonals AC and BD. Which information is not sufficient to prove ABCD is a parallelogram? Well, the first thing I would do is draw a picture and try to recall what I know about parallelograms. So we have quadrilateral ABCD, and we have diagonals AC and BD. So we're going to evaluate each of the choices here. Diagonals AC and BD bisect each other? Yes. In the parallelogram family, all of the figures in them have diagonals that bisect each other. Number 2, AB is congruent to CD. Yes, in the parallelogram family, opposite sides are congruent. And BC is congruent to AD. Yes, of course, opposite sides are congruent. Number 3, AB is congruent to CD. Okay, yes, because opposite sides are congruent. And AB is also parallel to CD. Yes, opposite sides are parallel in the parallelogram family. Number 4, AB is congruent to CD. Yes, we already established that. And BC is parallel to AD. So the best choice to prove that you have a parallelogram are the first 3 and not the fourth one. And the reason being is that if you do have opposite sides parallel, then they also must be congruent. And we're talking about two sides that are different here. So we're saying that sides AB and CD are congruent, but we're denoting that the other two sides are parallel. And in that case, how do we distinguish from a parallelogram or a trapezoid? Because we have one pair of parallel sides, and we can have two legs that are congruent, thus not having a parallelogram at all. So choice 4 is the answer. Number 14. The equation of a circle is x squared plus y squared plus 6y is equal to 7. What are the coordinates of the center and the length of the radius of the circle? So we need to group the like variables together, so x squared plus y squared plus 6y, and leave a space is equal to 7 because we're going to have to use completing the square in order to finish out this problem. So we're going to have to take 1/2 of 6, which is 3, and square it. So we get plus 9, and what we do to one side of the equation we have to do to the other. We're going to rewrite this in terms of one factor. So y plus 3 square is equal to 16. Bring down the x square. We're not going to perform the completing the square process for this value here because there's nothing to group it with. So it's understood that the center is equal to 0 in terms of x, and for y is a negative 3. And the radius is equal to the square root of 16, which is thus equal to 4. So 0, negative 3 is the center, and a radius of 4. That's choice 2. Number 15, triangles ABC and DEF are drawn below. If AB is equal to 9, and BC is 15, DE is 6, and EF is 10, and angle B is congruent to E, which statement is true? Well, the first thing I would want to try to do is try to see if these two triangles are similar. And if I can show that the sides are in proportion, I would be able to say that they're similar by side angle side. So the way in which I'm going to do that is I'm going to take the two values here, 9 over 15 for the first triangle, and set that equal to the corresponding sides of the other triangle. So the longest side is 10. I'm going to put that down here, and the shorter side is 6. I'm going to cross multiply, and if I get the values equal, then we can say that these two are similar. So 9 times 10 is 90, is equal to 6 times 15. That is also equal to 90, so I've just proven that they are similar. So I have choice 3, triangle ABC is similar to triangle DEF. But let's just check the other ones to make sure. So for choice 1, the statement is that angle CAB, so CAB, this angle right here, is congruent to DEF. Obviously not, because we were already told that the two angles are congruent. E is congruent to B, so that can't work. AB over CB is equal to FE over DE. Well, we can't do that because, as you can see, this side is shorter than this side, and you can't have that equal to the longer side to the shorter side. So that won't work. Proportion would not be written correctly, and it wouldn't be written in terms of corresponding sides, obviously. And for choice 4, AB over DE, okay, so the 9 over the 6, then we would have to go is equal to 15 over 10 if we started that way, and that's equal to FE over CB, so they're not using corresponding sides correctly, so choice 4 is out. Moving on to number 16, if triangle ABC is dilated by a scale factor of 3, which statement is true of the image for triangle A prime, B prime, C prime? So if we take a triangle and we dilate it by a scale factor of 3, then its image of the primes can't be multiplied by 3, so it can't be choice 1. B prime, C prime, which is a side, is equal to 3 times that of side BC. Yes, that would make sense. For choice number 3, the measure of angle A prime is equal to 3 times the measure of angle A. Well, when something's dilated, we have equal angle measures. It preserves the angle measure, so it can't be choice 3. We're not dilating the angle measures. And for number 4, 3 times that of the measure of angle C prime is equal to the measure of angle C, and I already discussed that the angle measures are preserved. We do not dilate them, so it can't be choice 4. Number 17, Steve drew line segments ABCD, EFG, BF, and CF as shown in the diagram below. Scaling triangle BFC is formed. Which statement will allow Steve to prove line segment ABCD is parallel to EFG? So the first and foremost I know that will prove lines that are parallel is if I can get either alternate interior angles congruent or there's a possibility of corresponding angles congruent, but this typically is the first and foremost. So can we say that angle CFG is congruent to FCB? CFG, FCB. Yes, because I have my parallel lines and I have alternate interior angles right there. So this will allow Steve to prove that the lines are parallel, but I'm going to check the other ones just to rule them out. Angle ABF, can that be congruent to angle BFC? BFC? No, obviously not. That's no good. Angle EFB, EFB, congruent to CFB, CFB. No, that's pretty obvious that they're not congruent. No way. And angle CBF, can that be congruent to GFC? No, those two don't have a relationship, especially not showing or proving alternate interior angles or corresponding angles, so that's no good. So it's definitely choice 1. Number 18, in the diagram below, CD is the image of AB after a dilation of scale factor K with center E, which ratio is equal to the scale factor K of the dilation. So when I evaluate this, I'm thinking in terms of corresponding sides again. And when I go through all the selections, EC over EA, those correspond, those particular sides. BA over EA, okay, those are not corresponding. EA over BA, okay, not corresponding. And EA over EC, we always start with the second image over the first image, so it's EC over EA. Number 19, a gallon of paint will cover approximately 450 square feet. An artist wants to paint all the outside surfaces of a cube measuring 12 feet on each edge. What is the least number of gallons of paint he must buy to paint the cube? When we talk about painting that needs to cover 450 square feet and all outside surfaces of a cube measuring 12 feet on each edge needs to be covered, we're talking about surface area. And surface area is the sum of all the areas of each of the faces. So being that it's a cube, we have square faces, and we know that each edge is the same value. So there's 6 faces in a cube, and the area of each face is 12 times itself. So we get a surface area value of 864. And 1 gallon of paint covers 450 square feet, so we're going to divide that by 450 and get 1.92, so that means we would need 2 cans of paint in order to paint that cube. Number 20, in circle O, shown below, diameter AC is perpendicular to CD at point C. So the diameter with the tangent creates a right angle, and chords AB, BC, AE, and CE are drawn. Which statement is not always true? Angle ACB is congruent to BCD. I'm not sure if that's not always true, but let's evaluate the other ones to make sure. Angle ABC is congruent to ACD. Well, we know that ABC has a right angle because this angle opens up to the intercepted arc of a semicircle. So that means it's 1/2 the arc of 180, so that is a 90-degree angle. So this is true. Can't be the answer. Choice 3, the measure of angle BAC is congruent to DCB. So BAC is an inscribed angle that opens up to this arc BC. And they're asking or checking, we're checking to see if it's congruent to angle DCB. So DCB, they are congruent because it is also an inscribed angle and it opens up to the same arc. So this is true. And angle CBA is congruent to angle AEC, and this is also a right angle because this inscribed angle opens up to a semicircle, which is arc ABC. So 1/2 that measure, or 1/2 that arc is 90 degrees. So this proves to be true. So this is the obvious answer. Number 21. In the diagram below, triangle ABC is similar to triangle DEC. And if I know that two triangles are similar, that means sides are in proportion and angle measures are preserved. And that's corresponding angles are congruent or the same. And corresponding sides. So everything's in terms of corresponding sides and corresponding angles. If AC is 12 and DC is 7, DE is 5, and the perimeter of triangle ABC is 30, what is the perimeter of DEC? Well, the first thing I need to know is a corresponding side. So the two corresponding sides are AC and DC. And since I'm looking for the perimeter of DEC, I have the perimeter of ABC. I can cross multiply and get the perimeter of DEC. So 7 times 30 divided by 12 is equal to P, which amounts to 17.5. So just like the sides or corresponding sides are in proportion, so are the perimeters. Number 22, the line 3y is equal to negative 2x plus 8 is transformed by the dilation centered at the origin. Which linear equation could be its image? So if we have a dilation of a line, we know that we're going to get another line that is parallel. So the first thing that I'm going to do is divide out the 3 here in order to get what this equation is in terms of y. And I have a slope that's negative 2/3 x plus 8/3. So as I stated earlier, a line that's dilated is going to yield another line that's parallel. So if we evaluate the slope here, which is the coefficient of x, parallel lines have equal slope. So I'm going to solve all the other equations in terms of y and see which one has the same slope. So that's where I'm going to start. So I have 3y is equal to 5 minus 2x, and divide out the 3. And I get y is equal to 5 minus 2/3 x. So right here I have the same slope. So the coefficient is negative 2/3, so this looks like it's going to be the answer, but I'm going to prove that the other ones are not the answer. So in this case I have 2x minus 5 is equal to 3y. Divide out the 3, and I get positive 2/3. So that is not a line that is parallel. So for this one, I get 2y is equal to 5 minus 3x. Divide out the 2, and I get y is equal to, we have a slope of negative 3/2, and I needed negative 2/3, so this does not work. And for choice 4, I'm going to add the 2y and subtract the 5. Divide out the 2, and I get a coefficient of x of 3/2. That is not a negative 2/3, so it's not the same slope to yield it or make it parallel. So it's choice 1 in this case. Number 23. A circle with a radius of 5 was divided into 24 congruent sectors. The sectors were then rearranged as shown in the diagram below. So as you can see, this is 1/2 the circumference of the circle, and here's the other half. So we want to know or find the value of x. So this is the distance, the circle for the semicircle. To the nearest integer, the value of x is. So we know that the circumference of a circle is equal to pi d, or 2 pi r. And I have a radius of 5, so we can use 2 pi r. But you have to understand or visualize that we are going to take 1/2 of that because we're finding the value of 1/2 of the circumference of the circle, which is our value for x, and not for the whole. The other part up here would make it the full circle. So we're going to divide out the 2, and we get c is equal to pi times r. We know the value of r is equal to 5. So to the nearest integer, 5 pi is equivalent to 15.7, which rounds up to 16 for the nearest integer. So that's choice 2. Number 24, which statement is sufficient evidence that triangle DEF is congruent to triangle ABC? AB is equal to DE, and BC is equal to EF. That's just stating that two sides are congruent, so that's not enough. So in order to prove congruency, we have to fab 5. So let's just talk about that real quick. We can have side, angle, side. We can have side, side, side. We can have angle, side, angle. We can have angle, angle, side, and we can have hypotenuse, leg. So if we get any of these arrangements, then we can say that something is congruent. So showing that two sides are congruent does not yield two triangles congruent. So choice 2, angle D is congruent to angle A. Okay, so A and D. B is congruent to angle E. And angle C is congruent to angle F. Does not prove triangles congruent. You can prove two triangles similar by angle, angle, but you can't do that with proving triangles congruent. So choice 2 does not work out. Number 3, there is a sequence of rigid motions that maps AB onto DE, BC onto EF, and AC onto DF. So that means we have congruency here, so AB to DE, BC onto EF, and AC onto DF. So we have side, side, side in this case, so it appears as though choice 3 would be a good candidate. But let's just check choice 4 to make sure. There's a sequence of rigid motions that maps point A onto point D. Okay, we're just talking about points. We're not talking about any angles or anything. We have side AB onto DE and angle B onto E. So we're just talking about one angle and a side. So that just has side angle. So this does not work. So we're left with choice 3 as being the correct answer. This concludes part 1 of the multiple choice. Please check with the other videos for part 2s, 3s, and 4s.